Hello, welcome to yet another promotional video of our QA course. The link to the course is in the description below. So I'll be talking about a key points of finding the unit digit of any power. These are just some of the highlights. The topic is not covered in its entirety, so don't base your complete CAT preparation on it, but I'll make it worth your time. We will talk about the key points and also solve 10 questions from this, right? So the first thing to notice in this is, what does it depend upon? It depends only on the unit digit. So the answer depends on unit digit of A and not the entire A as compared. So what I mean by that is, if I have 450 or 37 raised to some number, the answer to this will depend only on 7, and this 4, 5, 3 are of no use to us. So my first attention will only go on the unit digit of A, and it will also depend on N. And N, so I'll come to this N in a moment. So when I talk of unit digit of A can only have limited values. The value that it can be is only 0 or 1 or 2 or 3, 4, 5, 6, 7, 8, 9. So 0 to 9, there can only be 10 possibilities. So I just need to check for these 10 possibilities. And for these 10 possibilities, as N, so as N is going to change from, I'll start from 1, it could go to 2, it could be 3, it could be 4, and we'll see that if it takes any further values, the unit digit are going to repeat in cycles. So actually no value beyond 4 is going to be very relevant for us. So 0 raised to anything will always be a 0. There's nothing here to worry about, whatever N is. So it will always be 0. It will continue. Yeah, this will continue as 0. 1 raised to anything is going to always be a 1. So again, the value of N being 1, 2, 3, 4 here is not relevant. For any value of N, the unit digit will be 1 itself. For 2 raised to 1 will end with a 2. 2 square will end with a 4. We know these values. 2 cube is an 8. 2 raised to 4 is a 16. I am interested only in the unit digit of that 16, that is 6. And 2 raised to 5 will be 32. So what we'll see hereafter is, this is going to repeat. The 2, 4, 8, 6, 2, 4, 8, 6, it will repeat this way. So for 3, these cycles you would need to know. I'm just telling you fast how you have to do. 3 square, you would know the value. 3 cube, 27. Only worry about the 7. 3 raised to 4 also you would know, 81. 8, because we want only the unit digit. And 3 raised to 5, ideally if you are targeting the 99 percentile plus, you need to know it's 243. So the unit digit will come back to 3. And again it is going to repeat the same way, students. So 3, 9, 7, 1. And the way you can create this on your own right now is, you are successively taking the power of 3. So you multiply the previous one with 3. 3 into 3, 9. 9 into 3, 27. Worry only about the unit digit. 7. 7 into 3, 21. That's a 1. That 2 is immaterial. And 1 into 3 will be 3, and you will again continue. 3 into 3, 9. 9 into 3, 27. 7 into 3, 21. 1. 1 into 3 that way, right? Remember, for 3 we were multiplying successively by 3. For 2 you will multiply by 2. 2 2's are 4, 4 2's are 8, 8 2's are 16, that's a 6, 6 2's are 12. That's a 2 again. 2 2's are 4, 4 2's are 8, and so on, right? With a 4, if you do the same process, you should be a step ahead of me. 4 square, you know it also, or we have said 4 into 4, 16. Worry only about this digit. 6 into 4 is a 24. or 4 cube is a 64. The last digit is a 4 again. You see that it's repeated. So this is even smaller than a cycle of 4. So it's 4, 6, 4, 6 and it will continue repeating. For 5 it will remain a 5 irrespective of the value of n. Always it's a 5. For 6 it's always a 6. So quite a few of them are very easy also here. For 7 is a little unusual. It's same as 2 and 3. So 7 square 49. Focus only on the unit digit 9. 7 cube. Now you can do 7 into 9, 63 and take a shortcut that it has to be 3, but you need to know 7 cube, students. You can't say you don't know 7 cube and you are targeting for the IMs in that case. Okay. In fact, 7 raised to 4 is also known 2401. So it should be direct. 7 3s are 21, 1 and year after it is going to repeat. And for 8 8s are 64, 8 cube 512, 8 4s are 32, that's a 2. 8 raised to 4, probably the first time I'll say, okay, you might not know it. But again, 8 raised to 4, now, why do you look at it as 8? Isn't it 2 cube? So 2 cube raised to 4 is 2 raised to 12 and 2 raised to 12 you should know. 2 raised to 10 is 1024. Always go that extra mile. 2048, 4096. It will end with a 6. Or else you could have simply multiplied with an 8. 8 2s are 16. 6 will be the unit digit. Even if I don't know the entire 4096. And after 6 8s are. Now you might say I would not know 8 raised to 5. 8 raised to 5 is 2 raised to 15, which I might not know. But can you do 6 into 8 is a 48. So do you again get back 8? And then 8 into 8 is a 64. That's a 4. So the repeat will start here again. And with the 9 you are going to have same like a 4. 9 9s are 81. You get a 1. 1 into 9 you'll again get a 9. 9 into 1 you'll get 12. 9 1 9 1 9 1. So if you notice this, some of the most easiest ones are 0 1 5 6 are direct. They'll always be the same value irrespective of n. For 4 it's 4 6 4 6 4 6. So for 4 and for 9, okay, for 9 it's 9 1 9 1 9 1. Okay, so here you only check whether it is 4 to the power odd or 4 to the power even. That's the only thing that you would check. So for 9 depends upon the unit digit of A. If A is 4 or 9, what do you check about n? You only check whether it is odd or even. So 9 raised to odd will end with a 9 is as good as 9 raised to 1, or 9 raised to even. 9 raised to even 2 can act as a representative even value. So 9 square is 81. So it will end with a 1. 9 1 9 1 9 1. Right? So the only things that are difficult slightly would be when the unit digit of A is either 2 3 or 7 8. These are the only values which pose some sort of resistance. That is very easy. So what is the process in this case that you do? For the case of 2 3 7 8 being the unit digit of A, you would let me write it here. Let me write the process here for these two cases. You take n, you will divide n by 4. Why 4? Because there are 4 distinct values in the cycle. Hence you will divide by 4 and you are going to check the remainder. So this is the process that you need to follow. Once you identify unit digit of A is 2 3 7 8. Take the power, divide by 4 and search for the remainder. Now, the remainder could be, either the remainder could be 1. In that case, it will be the first of the cycle, and these cycles you should be able to reproduce it at that moment. Don't waste memory pass to remember it. Or the remainder could be 2. In this case, then it is going to be the second in the cycle. Or the remainder could be 3, third in the cycle, or the remainder could be 4, 4 as in 0. 4 as in 0. So when remainder is 0, the unit digit is the 4th in the cycle. Okay, and this tells me that for n, what happens is you only need to check whether n is a multiple of 4k plus 1. So this is the form that when the remainder will be 1, it's a multiple of 4 divided by 4, 1 left over, or it will be a 4k plus 2, or it will be 4k plus 3, right? Or it will be a multiple of 4 itself. Yeah, plus 4 will not write or plus 0 will not write. We'll just write it's a multiple of 4. So whether n can, I'm not even really interested in the value of n per se. I'm only interested in, is it a multiple of 4 and how much more? So 4 cycles, how much more than a cycle? 1 more than a cycle, 2 more than a cycle, 3 more than a cycle, end of the cycle. 0, end of a cycle. Repeat, 1 more than a cycle, 2 more than a cycle, 3 more than a cycle, end of the cycle. That's it. So that is how you do the process, students, right? So it should not be very tricky. Almost 70-80% of the questions you can just manage it on this idea. Then there are some difficult questions. When we see them in the exercise, we will check out what do we do with them. I'm taking the exercise from a course. Yeah, the number systems by me, and there's this. So we have finished divisibility rule. We are talking about unit digit of a to the power b. There are 3 lessons in it. So this talks of unit digit of 4 raised to n, 9 raised to n. The next lesson talks of 2 raised to n, 3 raised to n, 7 raised to n, 8 raised to n. So these lessons have details in them. Then there are some tough questions that we have solved over there. And there's an exercise just based upon this. So this is the exercise. So I'm directly going to go ahead, view the results, and I'm going to view the solutions or the questions. I just want the questions. Let me just make this full screen and let's solve. So the first question is, find the digit in the units position of this product. So a standard question on unit digit, it's just a product. So take individually, take this number individually, take this number individually, find the number, what is the unit digit, and just worry about the unit digit. Don't worry about anything else. What is the unit digit of the second number? And when you multiply these, the unit digit will multiply and will lead to the unit digit of the answer. So our first logic is I'm just focused on the unit digit. So for unit, this question is unit digit of 43 raised to 34. So we said we are interested only in this unit digit of A, that's a 3. So since it's a 3, the next step is going to be the 34. The n is equal to 34. We divide this by 4 and we check for the remainder. So 4 8s are 32. The remainder that we get is 2. So it is the second in the cycle. Second in the cycle. And what is that cycle of 3 raised to n? This is how you make the cycle. Remember 3, then multiply it with the 3 again. 3 3s are 9. 9 into 3 is a 7. 27. Worry only about the unit digit. 7 into 3 is a 1. So it might seem quite a bit right now, but this is so very fast. If I don't have to verbalize this into 3, it is as straight as 3, 9, 7, 1. 3, 9, 7, 1. You do it and it will stay in your memory without the need of you mugging it up. So second in the cycle, so the unit digit here is going to be 9. The unit digit of this is going to be 9. So this is a number which ends with a 9. So I'll put a 9 here. Right? And this is unit digit of 34. 34 raised to 43. So I'm only interested in 4. Now change tracks. Because this is a 4, you only need to check, is it 4 raised to odd or even? Which one is it? It is raised to odd. So if it is 4 raised to odd, it works as good as 4 raised to 1, and the unit digit will be a 4 itself. So this is a number with the unit digit being 4. And a number ending with a 9 multiplied with a number ending with a 4, the unit required answer will be 6. Is that the answer? That's the answer. Straight, simple. Next question. So questions would get a little tough as we move ahead. What is the units position of, very similar to the previous one, the only difference is there's a subtraction now. So the same idea we are going to do. So we want the unit digit of 18 raised to 35. So the 1 is of no use. 8, first point to focus. 8 in our cycle, remember 2, 3, 7, 8 have cycles of 4 different values. So since it's a 8, the next thought will become take the n, divided it by 4 and find the remainder. Find it. So 32, 3 is the remainder. So this 3 means it is third of the cycle. So recreate the cycle. And so what is the cycle? Remember, you have to go back to the base 8. 8 into 8 itself, right? That is a 64. 4 into 8 is a 32. There's a 2. And doesn't matter what comes next. I want the third in the cycle, which is 2. So the unit digit of this is a 2. So this is a long number which will end with a 2. So repeat the unit digit of 17. So I'll only worry about 7 raised to 25. 7 also has a cycle of 4. So 25 I will divide by 4. The remainder is 1. First in the cycle, what cycle? 7. 7 into, oh, so the first itself. Now, so forget whatever is that, the first itself. So this is a long number ending with the 7. And the unit digit of 16 raised to 15, this is a 6. For 6, remember, the cycle is always 6. So this is always, irrespective of the n, it will always be a 6. So this is a long number ending with a 6. Now don't forget what maths do you have to do. You have to do the first one minus the second minus. So here if I take, I am subtracting these numbers. Remember, I am subtracting them numbers. Okay, so you could take a minus common and the 7 plus 3 is going to become a 13. 7 plus 6, sorry. 7 plus 6 is a 30. But if you have to subtract, you'll carry from here. If you carry a 1, this will become 12. 12 minus 7. 5. 5 minus 6, we still go into negative. So I'll carry a 2 from here. So this is 22. 22 minus 7. That's a 15. 15 minus 6. The end digit will be a 9. The end digit will be a 9. Yeah, you could even club this, do this your own way. So these two together, if I take the minus common, this is going to be sum. Then this will end up with a 3, 7 plus 6, 3. So something with a number ending with a 2, subtract a number with a 3. So you'll take 1 carry forward and then 12 minus 3 will be a 9. Whichever way you do that doesn't matter. Okay, do not wait time. So here the carry was 2, here why is it only 1? Because here I'm not subtracting a 13, I'm just subtracting a 3. The rest all you don't have to worry about. Yeah, the unit digit will depend only on the unit digits, that's it. So the answer here should be a 9, and 9 is the answer here. A little, remember when you are subtracting, I would, just to be careful, I would check. Hopefully, you know, I'm always subtracting a smaller number from a larger number. I just do that check. Now 18 raised to 35 18 itself is a bigger base than 17 and 16, and raised to 35. Now 35 is a much larger number than 25 and 15. So that one check, the hygiene check works. Okay, this is a much larger number, and from these larger numbers I am subtracting a smaller number, so the answer is going to remain in positive one. So 9 is, I don't see any problem with the 9. Could there be a problem? Well, not really, but just in case, sometimes the question setup wants to play it nasty, he might throw in some spanners there. But that is for some other day, right? So let's go. That's just 2 questions done. Good question. So here we come to, let me go back to the theory bit over here and say, now there is a lot of people, when you need to find the unit digit of a raised to m raised to n, and remember there are no brackets over here. So first of all, so let me just do that. A raised to m raised to n. Now this is a usual indices rule. So this is, I think so, there's nothing new here. And from your rules of indices, you should know this number is as good as a raised to m into n. So here the index is m into n. So what we will do is, so this is as good as a raised to n. So instead of n, you have m plus n. So what we will do is, you will think that the power is nothing but m into n, and accordingly you are going to next continue checking. So you are going to check whether this is even or odd. Yeah, if it is a case of 4, you are going to check whether this is an even or odd. Or what else can we do? We take the index, we divide it by 4, and we check the remainder. So these are the usual 2 things that we check for the power. But here there's no bracket. So this does not mean m into n. So now there's a lot of people, students, who make this error of taking m and checking m whether it is even or odd. Or you take m divided by 4, what is the remainder? Now this is wrong, students. It's not m. The power here is not m. The power here is m raised to n. So this is the kind of number that we have. So what we would have to do is, we would have to check m raised to n. Is m raised to n even or odd? In the case of a being having unit digit 4 or 9, or you take m raised to n, and this whole number divided by 4, what is the remainder? So be very clear, it's here in this case it's m into n, whereas here it remains m raised to n, but in no case are you going to use an m, students. Yeah, you cannot isolate that n and just say that the power is m. That is very elementary error, students. Okay, so this is the complete theory. We have to go back to the questions. I guess 2 questions here. So here, so if I want to write this again, so a little more larger font, this is 9 raised to 11 raised to 10. So here your a is this 9 itself, and this full thing is n. So n is not equal to 11. N is equal to 11 raised to 10. And since this is a case of 9, we will check the power, that is 11 raised to 10 is odd or even. That's it, what we need to check. So the question is as easy as this, right? And now you might say 11 raised to 10 is actually, if you did the classification lecture, we said the polarity of the power is same as the polarity of this number. 11 is odd, so 11 into 11 into 11 into 11 any number of times. 11 raised to 10, essentially always go back and think, what is that number? Isn't it 11 into 11 into 11 into 11 into 11? So there's a series of 10 11s. So all are odd, no? So this is not, there's no multiple of 2 over here. There is no multiple of 2. All are odd. So you should remember all this. Now all this is a waste of time. This is nothing but what is it? It is odd. So what is the thing that we are looking at? 9 raised to odd. 9 raised to odd, you could think of it as good as 9 raised to 1, which we know is as good as 9. So the unit digit is 9 over here. That will be the answer. Okay, I'm not spending more time here. I think it's an easy one. And if it isn't, things would be nasty. Now this question, a lot of students asked out in this question. Find the unit digit. So the stage is set, digit in the units position of this. So again, if you look at this number 18, now you should be wiser from the last question and say, yes, A is equal to 18, but N is this full number. This full number is equal to N. N is not 18. Again, N is equal to 18 will be wrong, students. It is 18 raised to 18 raised to 18. Anyway, so let's come back. So this 1 is of no use. So I'm going to check this is an 8. And since this is an 8, we will take our N and we'll divide it by 4. So this in our case right now, and check what is the remainder. And this in our case, N is, again, let me do this error and show. Okay, let me do this error. I take 18 divided by 4 and the remainder is 2. And hence it is becoming the second in the cycle. There are people who are going to do the cycle of what? So let me complete this 8. 8 into 8 is a 64. So the answer is 4. All of this is wrong. It is not 18. N is not 18. So this whole thing goes wrong and this is not the answer. Then what do you need to check? You need to check it is 18 raised to 18 raised to 18. And for those who don't know this, okay, give me a minute. For those who don't know it, this is as good as, and this is a skill that you need to develop, is 18 raised to some number, some large number, which is 18 multiplied with an 18 multiplied with an 18 and a lot of this. And what you should see, this is 2 into 9, 2 into 9, 2 into 9. Factorization is a very simple thing. So this is a multiple of 4. And if it is a multiple of 4, N when divided by 18, the remainder is 0 because it's a multiple of 4. You know, you can divide this full thing by 4. The 4 will cancel out. When it cancels out, what is the leftover? Cancel out means it's completely divisible. The remainder is 0. So the remainder is 0. So by 0, what we mean is it is the last in the cycle. And what is the cycle of 8 now? Now you'll have to go back to this base. 8, 8, and now I'm not writing this all, I'm just mentioning it. 4, 4 8s are 2, 2 8s are 6, 6, and we know that it will repeat after this. So the last in the cycle is 6. So the answer is a 6 and is not a 4. So next question, fifth question, pretty easy question, for which now the Simple thing till now is most of the time the values of n, the index were given and we needed to find the unit digit. A simple way to trouble students is, for which of the following values of n will the unit digit of all these numbers be the same? So we are not asking to find the unit digit. We are saying that the unit digit is same. Now comment on the value of n. And which of the following, for anyone who has a trouble, it's which of the following. So you could even take the options and check. Okay, but then I think it's time to use a revision over here. We see a 2, 4, 4 will be 4, 4, 6, 4, 6. It will always be 6. This will have 4. So the cycle, the longest cycle is that of 4. So I would take n, the general case of n could be, it could be a multiple of 4k plus 1 or 4k plus 2. Now this is too extensive a theory for this question. Or it could be 4k. So these are the 4 formats of n which is important. And there cannot be any other format. When you divide by 4, the remainder could either be 1, 2, 3 or 0. 0 means it's complete multiple. There can't be anything. I am not interested in this k value. Is that okay? I am just interested in what is the form of it. And depending upon it, 2 raised to n will end either with a 2 or a 4, 4 into 2. That's an 8, 8 into 2 is a 6. Here also there is an error prone area, students. So I did not mention this earlier, so let me mention it here. What happens is, when you find this cycle, many times students do 2, 2 2s are 4, so that 4 is okay. Till the time you reach a 4, everything is good. But then they do 2 3s are 6, 2 4s are 8. So what is happening is, in their mind they are doing 2 1s are 2, 2 into 2 is 4, 2 into 3 is 6 and 2 into 4 is 8. So this is, we are not dealing with multiples of 2. We are not dealing with multiples of 2. Okay, so this is wrong. Wrong. We are not dealing with multiples of 2. What we are dealing with is powers of 2. Powers of 2. And for powers of 2, what do we do? So we say multiply it with a 2 and again multiply it with a 2. Don't do 2 into 2, 2 into 3. Do the previous one into 2. Do the previous one into 2. That is how you get the cycles. And you have done the theory somewhere, so you should know after 4 it is going to repeat. So this, so I'll have to erase this. So let me erase this up. A moment. So all this, let me erase it up. So the 2 will end with either one of these. And the 4 raised to n will end with a 4 or a 6. With a 4 or a 6. When will both be the same? Both are same only over here. So you should be able to manage and see the answer. But let's do this also. And this is where I said this is an overkill. Why? Your attention should have gone to this. This will always end with a 6. Always end with a 6. And if it ends with a 6, the others also have to end with a 6. So, anyways, there's only one cycle left. So, let me do that. 8 into 8, 64. 4 into 8, 32. 2 into 8, 6. And then it will repeat. So, if you see, all of them are same for k. So, n has to be of the form a multiple of 4. And this is not a multiple of 4. This is not any multiple of 4 will work. Okay, so again, not a tough question. I wouldn't count it as tough, students. These are all silly questions. Okay, slowly questions get a little more trickier. Nice question. It's a little lengthy. So first observe it. The question is again asking us the unit digit in the units position. Now it's a longish expression. So observe it always, students. Yeah. So what you should observe is 1 is the base is 1, 2, 3, 4 and it continues till 49, 50. And the index is a 3, always a 3. The index is always a 3. Okay, so that n is always a multiple of 4 plus 3 or 3 itself. 3 is a pretty small one. So you are going to, let's start. So I'll just start with this 1 cube. So let me leave it here, right? There are again some shorter ways of doing it. I'll just do it a little elaborate way. 1 cube will end with a 1, I know. 2 cube will end with a 8. Okay, 3 cube will end with a 3, 7. 4 cube with a 4 is going to be 4, 6, 4. 4 again. A 5 will end with a 5, a 6 will end with a 6. Now I'm continue writing till the time I see some repetitions. A 7 cube will end with a 343, you should know the value 3. 8 cube will end with a 2, 512. Yeah, no, 9 cube you should know 729, 9191 and so on. And 10 cube will end with a 0. Now if you see 11 cube, now it will start repeating. 11 cube will end with the same number as 1 cube ended. A 12 cube will end with the same digit as the 2 cube and so on. So I don't know 13 cube, though 13 cube also one should know, 2197. Okay, but then it will end with the same thing, right? Somewhere we are going to go, okay, now I do not know, but I don't really intend to know this. I should only be worried about 4 cube, same as the last digit of 4 cube. And that is where the repetition is starting. So it will go on till 20 cube and then it will come back from 21 cube. Okay, 22 cube will end with the same as this and then the 30 cube and then the 40 cube and then the 50 cube, and this is the end of the story. So I find the unit digit of the first row and that will be the same. So all these are going to end with the same. So let me write it here. So all these are going to end with a 1. Now pay attention, now it's interesting. All these are going to end with a 2, all these are going to end with a 7. And how many are there? They are actually 5 of them. 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. So there are 5 of them. So whatever you are going to add these up, you would have to multiply all of this with a 5. So you know the shortcut that I was talking about, or the amazing way is, without finding all these, when you multiply something with a 5, the ending digit will either be 0 or a 1. So a 0 or a 5. So these are not going to be my answer. It could either be a 0 or a 5. And when will it be 0 or 5? Depending upon whether it's an odd or an even multiple. But anyways, I don't think so in a pressure cooker like situation one will think that way. So let's just finish it. This 4 cube will end with a 4. This will end with a 5. This will end with a 6. 7 we know. This will end with a 2. 9 will end with a 919. And this will end with a 0. So let's just add it up, right? And again, okay, add 9, 16 first. It will help you in your making your sum faster. Na? 9, 16, 20, 31, 34, 36, 36 and 9, 45. 45 into 5, the unit digit I'm only worried about is 5. So the answer to this question is going to be 5. Good question. So next one. Okay, so a little camouflage question. So camouflage question means, in the sense here the question is asking us a remainder when divided by 10. So remainder when divided by 10 is as good as the unit digit of the expression. So while if you know the theory of remainder, this question could be pretty simple even with the remainder theory. 13 divided by 10 leaves a remainder 3, so 3 raised to 7. Okay, 7 divided by 10 leaves a remainder of 7 or minus 3. Either way, so that's depending upon whether you know the theory of remainder. But then, yes, you can do that, and that's also equally fast and a simple way, student. But since I'm dealing with the topic of unit digit, I'm just telling you this is a unit digit question. When you divide by 10, what is left over is always just what is there in the unit digit. And to find the unit digit, for the 1 is immaterial, 3, so 3. Ideally though, you should just know this. 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, 3 raised to 5, 3 raised to 6, 3 raised to 7. The third in the cycle. So third in the cycle is going to be a long number ending with a 3, 9, 7. And 7 also has a cycle of 4 values. So this you'll divide by 4 and you'll find the remainder, so which was 1. So that will also end with a 7. And what maths are we doing between the two numbers? We are adding it. 7 and 7 will end with a 4. So 4 is going to be the remainder when divided by 10. This is a long number, whatever this number is. Okay, when you divide it by 10, you would be left with 4 as the remainder. Just this part, the rest part will be a multiple of 10. Okay, so more questions. 8th, what is 8th? Okay, back to which of the following values of n will the unit digit be 9? So now the unit digit is given to us and n is asked. But n could be many values, so which of the following? So again, if you are smart enough, students, I look over here, this could have 4 different possible values. So n being a multiple of 4, and what remainder will matter here also. Here this will be just 4, 6, 4, 6. So n is odd even. So for 2 of the terms, it depends whether n divided by 4. So this is of the type 4k plus 1. 4 into 6, 24, 1 is the remainder. This is 1 more than them, so this is of the type 4k plus 2. This is of the type 4k plus 3, and when you do this check, you see all the above is also there. So let's take one of them and see what happens. Now if n is of this form, 2 raised to n will end with a 2. 2 raised to 1, the first in the cycle. 3 raised to n will end with 3 raised to 1. 4 raised to n will end with a 4 raised to 1. So the unit digit over here is 7 and 2, 9. So we do get 9. But remember, we also have all the above. So you would need to do a check here also. If n was of this type, so this is going to be 2 square, so end with a 4. 3 square, end with a 9. 4 square, 4 raised to even of 16, end with a 6. And the unit digit of this also turns out to be 9. So if 2 values are possible, it has to be for all 3. I'll leave it for you to find the individual unit digits and then check whether it adds up to a 9. Please do that work yourself. I'll go to the next question. Okay, so one of the toughest question of the exercise, very interesting. So let's take it in order. Why mess it up? So if A is 47 raised to 47 and B is 46 raised to 46, find the digit in the units position of A raised to B. So now if you look at this A raised to B, this is a number. And remember, it's given A is 47 raised to 47. Now remember, 47 raised to 47 is just a representation of a number. Like 64, I can write it as 8 square. But the number is 64. So in its basic sense, in its counting sense, everything is a number. So this is a long number. So think of this as just a number that is there. Its physical appearance looks different, but it is the same number. That raised to another number. This is also a long number. So, or else if I want to write this, what I'm trying to say, it should be clear, students, but what I find people struggle in such things. And that marks your graduation to problem solving approaches. What I'm saying is a raised to b, you need to understand, is a long number. Some long number raised to another long number. It's just that the way these are written is different. This thing raised to 46 raised to 46. So basically this box is your A. So if you go back to the original slide, this is your A. So I am going to be interested in what is the unit digit of A. And A itself is 47 raised to 47. So this is a question in itself. Find the unit digit of 47 raised to 47. So the 4 is of not of any use, 7 is of use, 7 has a cycle 4, so you'll divide this by 4, find the remainder. 11 4s are 44, remainder is 3, and because it is 3, it is the unit digit of this is the third in the cycle. Which cycle? That of 7. That is 7. 7 7s are 49. 9 7s are this. So this is the unit digit of this. So this is a long number ending with a 3. Okay. And now this number is n. Now what do you check of n? What do we check of n? It depends upon what was the unit digit. Right? If the unit digit is 0, 1, 5, 6, then n is immaterial. The unit digit will always be 0, 1, 5, 6. If this unit digit was a 4 or a 9, you would check n is even or odd. So that flowchart should be very clear, algorithm in your mind. This is a 3, so n number, this number, what are we going to do? We are going to divide it by 4 and check the remainder. And we have just today done this question. 46 raised to 46 divided by n by 4, what is the remainder? And if you do 46 divided by 4, the remainder is 2. I'm sorry students, but then you haven't really paid attention. It is not 46. It is 46 raised to 46. Which is 46 into 46 into 46 into 46. How many times? 46 times, which is a multiple of 2 or 4. And being a multiple of 4, when divided by 4, the remainder is 0. And because the remainder is 0, okay, the final answer that we have is the unit digit of this is the last in the cycle of 3, and the 3 cycle is 3, 9, 7, 1. So 1 is the last in the cycle. 1 will be the answer for unit digit of a raised to b. And students, the answer is going to change on. So had this number been this, so this is a different number, students. I'm not doing this question, but we had done one sort of this question. This is a different question than this format. Here the brackets and all are very important where they are. That is why it's given as a raised to b, and it's not just given as this number. Okay, so let's go ahead. One more question is left. Let's just finish that also. Let's see, is it interesting? Okay, yeah, it's a good enough. So this is actually, this question will again be counted as very easy. We just give this question because we know where the students are going to mess it up. You put in some variables and so on. Till now it was n. Now it's n minus 2 and n plus 4. And that is enough to put off a lot of students who don't understand the language of maths. Maths is just essentially a language. How many different values can the unit digit of this assume, take, or assume n to be a natural number greater than 2? One possibility is just take values of n and try it. Maximum you'll have to take 4 consecutive values of n. Okay, or else the theoretical way here is observe a little bit. So this is a 2, this is an 8, both have a cycle of 4 different values. So the index, I would be worried about the index. And what about the index? The index when divided by 4, what is the remainder? But the two indexes are different. Now start observing something. Na? N minus 2. So if you take n minus 2 and you go to n plus 2, you are essentially adding a 4. So n minus 2, this number when I divide by 4, what is the remainder? And n plus 2, when I divide by 4, what is the remainder? These are my individual questions to find the individual unit digit of this and this. But then you see that the difference between them is 4. So what you see is in both the cases, it's the same remainder. Whatever is the remainder in the first case, that same remainder will be in the second case. Why? Because you have just added 4 to it. So the 4 that you add gets divided completely, gets flushed out as the inner quotient. It will appear in that 4k part, 4k plus remainder. Remainder will remain same. And this remainder, what can be the remainder? The remainder itself could be 1 or 2 or 3 or 0. These are the only things. So the n minus 2 that I am saying, or n plus 2, whichever one which you take, will either be of the type 4k plus 1 or 4k plus 2 or 4k plus 3 or 4k. And these are the remainders. And if these are the remainders, the first number, 82 raised to n minus 2, will end with what? The cycle of 2. 2, 4, 4 2s are 8, 8 2s are 6. And what is the next one? 28 raised to n plus 2. This is 8. So it will end with an 8 or a 4 or a 2 or a 6. And what maths are we doing here? We are multiplying the 2. So when you multiply these two, you get 6 as the unit digit. Here also 6, here also 6, and here also we get 6, 6 into 6. So whichever the value of n minus 2 is, on all the cases the unit digit is always 6. So the question is asking us how many different values. So it can only assume one different value. So overall this topic is an easy topic, students, unit digit. We can try to make a few more questions. There's never dearth of questions. And your idea or approach of give me more tough questions to solve is wrong. You should try to learn the approach or the problem solving skills, or the theory is just this much. Now how do you apply? Even if you do, if I give you 5 more tough questions, in an exam I'll put in yet more new question, which will require you to think like what we are doing here. Right? So I get used to, just remember what you learnt is sufficient for all these questions. You just need to properly fit it into the picture.